Hey there. Welcome to this practice set on introduction to sets, which I guess now that I'm looking at it, the idea of practice set, it's a set of problems that you use to practice. All right, like this video, that was really nerdy. Like this video if you find it helpful, subscribe to the channel for more math help, drop me a comment or question, and please take a moment to check out some of the other videos that we have on the channel. As always, pause the video to work these problems on your own and then come back to check your work. Okay, so we're going to start out with just practicing the notation of sets. So first question is list the set of even numbers between 1 and 10. And I did specify in there include the 10. If you were taking a higher level math class and you were dealing with set theory, then we'd have to be more particular about how we phrased that so we would know what we were talking about. But the set of even numbers between 1 and 10. So that would be 2, 4, 6, and 8. Oh, include the 10. And question 2, list the prime numbers between 1 and 10. And that would be 2, 3, 5, and 7. Now, a prime number is a number whose factors are only 1 in itself, and 1 is not a prime number. 2, fun fact, 2 is the only even prime number because every other even number would have a factor of 2. And then we have 3, 5, and 7. It's okay if your set symbols are a little wonky. You got to make an effort. Okay, just got to make an effort, and you cannot make up like your own symbols. Like you have to try to do the squiggly brackets, and that's a terrible one. Okay, so don't beat yourself up. Now for 3, 4, 5, and 6, I put all these on one screen because I didn't order them probably the most efficient way when I type the slide. So for 3, we're looking for a union, okay? And we have 1, 3, 4, and 7 unioned with 1, 2, 3, and 4. And so we're going to join them together in holy matrimony, all right? So we're going to merge these together. So 1, we're going to start with the 1. And 1 does appear in both of them, but we do not list it more than once. Now, I am going to try to do this in numerical order. So I'm going to come to the 2 next. However, if you went with the 3, that's not wrong. 2 does not appear anywhere else. Now I'm going to move to the 3. 3 is in both of them. And then we'll do the 4. 4 is in both of them. And then coming over to this first set, I've got 1, 3, 4 already covered, but I don't have the 7. So we'll do that. And then jumping down to number 5, it says represent number 3 as a Venn diagram. So I'm going to set up my Venn diagram. And I want to look, is there anything in set 1 over here, the first set, that is only in the first set and not in the second set? And that would be the 7. So the 7 would be in this piece. Overlap, 1 overlaps, 3 overlaps, and 4 overlaps. So 1, 3, and 4. And then that second set, the 2 is in that second set, but is not in the overlap. And there we go. Question 4, we have the set 1, 3, 4, 7, and 10, and we're going to intersect that with 1, 2, 3, and 4. And remember, the intersection, you're looking for where the sets overlap. So I'm just going to run through this first set and just see, is what's an overlap. So I have 1 is in both. 3 also is showing up in both. And 4 is showing up in both. And we can just double check 1, 3, 4, and then 7 and 10 are not. So that is my intersection. And then question 6, represent that as a Venn diagram. I've got the intersection, so I'm just going to go ahead and put the intersection in there where that overlap is. So that's the 1, 3, and the 4. And now kind of looking through and seeing what is in set 1 or this set over here that's not in the other set. That would be the 7 and the 10. And then over here, I think we just have the 2. I'm just going to pick up the 2. And I should probably number these. This was what, problem 5, and this one was problem 6. All right. Now, remember, it does not matter if you have the numbers out of order. So if you have that answer there and the numbers are all jumbled up in a different order, as long as they are the same set of numbers, you have the correct answer. We just will try to write them in ascending order just to preserve the sanity. And in a class, you might put them in that order. Your teacher might require it, not because it's more correct, but because your teacher is going to correct 20, 30, 40, depending on the size of your class, papers and need some kind of consistency in order to not go crazy. What is the even numbers intersected with the odd numbers? Well, that would be the empty set. And if you think about it, your even numbers, 2, 4, 6, 8, 10, and it would go on forever. And you intersect that with like 1, 3, 5, 7. And you can tell there's these are what are called mutually exclusive sets. So that I just threw some more set vocab at you, but mutually exclusive, meaning if it's in one set, it cannot be in the other set. Okay, being in the set of even numbers automatically means it cannot be in the set of odd numbers. So that is an empty set. Okay, for 8 and 9, write the mappings of the ordered pairs. So I apologize for how not super clear that is, but we work with what we've got. So in that first one, the number 1, I'm just like tracing the number 1. 1 is mapping to a 3. 2 is mapping to both 4 and 6. So we write that as 2 is mapping to 4 and 2 is also mapping to 6. And the 3 is mapping to the 7. So if you maybe messed up like the 2 being mapped to 2 different things, 2 went to 4 and 2 also mapped to 6. Maybe you just weren't sure what you were looking at or thought there was an error in the arrow or go ahead and fix that now. But that's what that is. Like that 2 was mapping to 2 different things. In the bottom one, we have 4 mapping to a 2. We have 6 also mapping to a 2. We've got 8 mapping to a 3 and 10 also mapping to the 3. Okay, now if you have already studied, maybe not this so much, but you've studied patterns in the ordered pairs and stuff, you might know where we are going with this. Like that there's something special about set 8 and set 9, something that makes them different. And that is where we're going to go for like the next lesson. All right, last one. List the ordered pairs for the mapping, then graph them. And what do you notice? So in this one, we have 0 mapping to a 1. We've got 1 mapping to a -1. And we have 2 mapping to a -3. All right, so let's go plot them. So 0, 1 is right here. 1, -1 is right there. And 2, -3 is right there. And what you were intended to notice was that they form a line. Okay. And one of the questions that I asked in the video was, or that we talked about was, is there a pattern to the relation? Like when you're doing that mapping, like, is there some kind of pattern? And the answer was yes, usually. Well, one of the patterns that you might see when you map them is that your points form a line or maybe some other kind of shape. And that's where we open up the discussion of a relationship between sets of numbers. So that's as far as I wanted to take it in talking about sets and mapping. Hopefully you found this helpful, and it will lay the groundwork for the next lesson where we will introduce one of the key concepts in all of math. Hope to see you in that next video.